This is so exciting. We get to do trig identities. I'm sorry they're fuzzy. I just didn't have time to retype them all. But your first main trig identities are called your reciprocal identities and your ratio identities. And your reciprocal identities are cosecants 1 over sine, and secants 1 over cosine, and cotangents 1 over tangent. And that tangent is sine over cosine, because remember that's y over x, and cotangent is cosine over sine. So pause this, write them all down, and then we'll look at some examples with the ratios. Our first example is going to be simplify sine x secant x. So sine x times the secant of x. So your goal is to not have really cosecant, secant, or cotangent in front of you, but just to get them in sines and cosines. So this would be sine of x times 1 over cosine of x. That simplifies to sine of x over cosine of x, and that simplifies to tangent of x. You're simplifying trigonometric ratios based on your identities. The list of identities is on the left-hand side of the screen. Let's do 2 more of these. Let's simplify cosine of x over cotangent of x. So I want to write these both in terms of sine and cosine. So this is going to be cosine of x over cotangent. Tangent's sine over cosine, so cotangent is cosine over sine. When you divide by a fraction, you multiply by the reciprocal. So this is equal to cosine times sine over cosine. And the cosines cancel, and you end up with sine. So cosine over cotangent is equal to sine. Sometimes writing everything out confuses me. So sometimes I do things like this. I'll go cosine is x and cotangent is x over y, and that's equal to x times y over x, which is just equal to y, and y is sine. But then that's kind of like doing everything in your head and not showing your work, and you have to show your work. So it's nice to do stuff like that, but you can't do it like that and show your work. So let's look at this problem like that. We'll look at how to do it in our head and then how to show our work. Cosecant is the hypotenuse over the opposite, and cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. And so the hypotenuses cancel, and those cancel, and those cancel. That's 1. Look at that. That was so nice. But if I'm going to show my work with algebra, cosecant is 1 over sine times cosine times tangent, which is sine over cosine. And now I'm a much better math student, and it's equal to 1. But I think you should know how to do them in your head, because when you hit calculus next year, the kids that can magically do these in their head can speed through these problems a lot faster. And if you're having to show your work, it's a little bit slower. So think of this as the in your head method, and this as the showing your work method. These trig identities are called the Pythagorean identities, and you'll have to memorize them as well as you have Pythagorean's theorem memorized. Now the first one, sine squared x plus cosine squared x is equal to 1, is really just Pythagorean's theorem, because remember, the sine is the y value and the cosine is the x value, and on a unit circle, this is 1. So the Pythagorean identity, saying sine squared plus cosine squared equal to 1, is just Pythagorean's theorem for that triangle. Now, we're also going to do proofs in this section. And the proofs are going to be asking you to do things like prove this function. 1 plus tangent squared equals sequence squared. So if I had 1 plus tangent squared, that's 1 plus sine squared x over the cosine squared x. And that's equal to secant, which is 1 over cosine squared x. So now I'm going to have to look at things like balancing equations. And I've got cosine squared on the bottom right here. where's my little arrow? I've got cosine squared on the bottom right here. I've got cosine squared on the bottom right here. So I need to get a common denominator and write this 1 as cosine squared x over cosine squared x plus sine squared x over cosine squared x equals 1 over cosine squared x. And now, since everything has cosine squared x on the bottom, I can multiply the whole thing by cosine squared x. Cancel, 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 cancel. And if you see the result is that cosine squared x plus sine squared x equals 1, which is the same as your basic Pythagorean identity. So, honestly, when I was taking calculus and pre-calcs back in the day, I only memorized that one because these other two are just variations of the first main Pythagorean identity. And so let me show you how to use the first one to memorize the other two. If you were to only memorize, and we'll need to add a new first Pythagorean identity, that sine squared x plus cosine squared x equals 1. If you were to divide that whole thing by cosine squared x, you'd have sine over cosine, cosine over cosine, and 1 over cosine, which is going to result in sine over cosine is tangent, cosine over cosine is 1, and 1 over cosine is secant. So you see, of those three identities, you just memorize the first one and you get the other two from them. Here's an example of what a problem would look like. Let's say you had 1 minus cosine squared x over cosine x. Okay. Your Pythagorean identity says that 1 is equal to sine squared x plus cosine squared x. So you need to recognize the top right here as a variation of this one. So if I were to solve this, I would get 1 minus cosine squared x is equal to sine squared x. So I can then, up here, replace this with sine squared x over cosine of x. And that is sine over cosine times sine. And so that ends up being tangent x sine x. You're basically doing algebra and rearranging. I think of it like simplifying fractions. Like when you're in algebra, you had to take 3/6 and reduce it to 1/2. Now we're doing trig, but we're reducing 1 minus cosine squared over cosine to tangent sine. And it's kind of fun, but it's completely new, and it kind of mess with your brain, and you just have to work through maybe more practice problems than I give you in the book to get the hang of them. So next I want to show you kind of how to do a problem wrong, which sounds weird, but with these problems, you're simplifying stuff. And sometimes when you start simplifying, it gets better, and sometimes when you start simplifying, it gets worse. So I'm going to take this problem, and I'm going to simplify it with two different sort of options. So let's say I looked at this as 1 over tangent squared plus tangent squared over tangent squared. So that would be cotangent squared x plus 1. And if you wrote down those basic identities from like the previous page, you'd see one of your Pythagorean identities is that 1 plus cotangent squared is cosecant squared. So here's the answer going this way. But let's say you didn't see that at all. Let's say you looked here at the 1 plus tangent squared x and you thought, oh, well, that's my secant squared identity. Secant squared x over tangent squared x. Now you're not doing this wrong, But secant x is 1 over cosine squared x, and tangent x is sine squared x over cosine squared x. And now you have to do the flip and multiply thing, so this is 1 over cosine squared times cosine squared over sine squared. The cosines cancel. That's 1 over sine squared x, which is cosecant squared x. Okay, so I shouldn't have said right and wrong. I should have said 1, 2, 3 steps to an answer. 1, 2, 3, 4 steps to an answer. And the fact that the person whose paper you're looking at makes no sense to you because you think like this, but they think like that. So my general advice is, if it starts to get really messy, start over, because there might be an easier way to do it. And if you're going along and you're feeling the love and it's making it look like it's a smaller problem, then just keep going the way you're doing it. But there's not a one way you have to simplify things. You can go completely different directions and still end up with the right answer. Okay, this next set of identities are called the co-function identities, and I recommend also not memorizing them. There's too much stuff to memorize in this chapter. It'll just make your brain hurt. So the co-function identities, don't memorize, think of the picture. Because if you pictured the sine graph, here's the sine graph. This is 2 pi, this is pi, this is pi over 2. So if you picture the sine graph, and then look right here, it says the sine graph is skewed to the left 90. If I take the sine graph and I take this point at pi over 2 and I move it to the left 90, and I take this point at pi and I move it to the left 90, take this point down here and I move it to the left 90, and I sketch that graph. If I take the sine function and I move it left 90, I end up with cosine. So if you have to do any of these replacements in a problem, all you have to do is not memorize 6 different things, but just picture the graphs moving. Here's an example. If cosine theta equals 0.34, find sine of theta minus 90. So you know that sine of theta minus 90 is the opposite of sine of 90 minus theta. And sine of 90 minus theta is cosine theta. And so the sine is negative 0.34. And I just realized I busted a move right here that we didn't talk about yet. So sine of theta minus 90. And I changed that to negative sine of 90 minus theta. Let's get a new slide to talk about that one. These are your odd-even identities, which I also don't completely recommend memorizing, but just picturing. And I say I'm not very visual, but when I'm doing trig, it's like the vision center of your brain should sort of be on fire. For example, let's look at the sine function. Here's the sine function in 2 pi. Here's the other side of the sine function. Okay. And I want to concentrate on this one. Sine of negative x equals negative sine x. So let's say I had to have sine of negative 90. That's right here. And sine of negative 90 is directly opposite of where sine of 90 is. That's why sine of negative 90 equals negative sine 90. I mean, maybe I had teachers that had me just write these all down and memorize them. I might have had that. But I think that when I was learning this, it was easier for me to memorize them if I pictured them as drawings of the sine and cosine graphs. So this might not seem quite as easy as I'm making it out to be, but I am really good at memorizing stuff. I mean, I was the kid that could just memorize everything, pass the test, and then the next day forget things. And when you start getting into trig identities, this right here is an intimidating list of stuff to memorize. So I want to look at one more example of how you would deal with it. Like if it said sine of negative x, or actually I think I just did sine, so let's do cosine. If it had cosine of negative x, picture a cosine graph. It looks like this on this side, and looks like this over here. And so the cosine, let's say we took, here's negative 90. That's the same as the cosine of positive 90. The cosine of negative 180, that's the same as the cosine of positive 180. So if you have the cosine of negative x, that's the same as the cosine of x, because those things are the same place on the graph. And that's it. So for these functions, don't memorize, picture.